So after this tutorial is finished, you'll get something that looks like this. You'll be able to move you'll have to click once, but you'll be able to track the cursor's position, using the tank's head. And then you rotate with A and D like a real tank. And then W will move it back, S will move it forward. So something like this. So you'll be able to kind of fight. And we'll get it so the camera tracks it as well. Something I want you to note is that all I did that was different from the in between tutorials is I just created a plane underneath it. And this is just the Unity plane I scaled up. Okay, so let's take a look at the code. So the first thing I want to do is create a variable that generates a plane, an actual plane. So, and this plane is going to actually store a plane that stores the direction of the face normals. Okay, so some of you might be like, well, what does that even mean? So let's take a look at this in Maya. So here's a plane, and this green line represents the face normal. Now, whenever you're shooting anything, like say you have a projectile, a missile, or you're shooting a ray, like a Raycast, which is what we're doing, it actually is bouncing off of the geometry, but more importantly, it's looking for the face normal, which is this line right here, to compute with. Now, with a character, you might have a 20,000 polygon character, so it's pretty easy to hit a face normal that's next to it. Now, we have to record the actual direction of the face normal. The reason why is when you rotate our plane, I'm going to click off of it, you can see that the underside of the face or the plane does not store any data. So if you have a character and he has a big hole in his body and you don't have any geometry on the inside there, if you fire a sphere at the underside of this or a bullet, it'll actually just pass right through. Again, because it records all the data on the face normal. So let's go ahead and generate a plane that's going to sort of sit invisible on top of our other plane, and it's going to record all the data. So the data type is just the word plane. And I'm going to create a variable called player plane and make that equal to a new plane. Now this new plane is going to store a couple things. It's going to store actually two things. It's going to store the direction and the overall position of the plane. So the way we record the direction is just like anything else. We do vector3 dot up. And then we have to record the transform dot position plus the new vector3, and then we're going to do 0, 0, 0. Alright, let me zoom out so you can take a look at that code a little bit better. I'm going to make this lowercase here. The next thing I'm going to do is I want to create a ray. Now, if you haven't seen the video on Raycast, then you should go back. This is going to store, I should just say this stores the position of the mouse in relation to the camera. So our camera is actually going to be the one that's shooting the ray, and it's going to be tracking our mouse on the screen. So we can say ray equals ray hit. This is our variable. Let's just call it Raycast. That might make better sense. So Raycast, and that equals camera dot main, and then we need to record screen point. Oh, you know what? This should have just popped up. So camera dot main. I've become really used to not having to type everything because of IntelliSense. Screen point to ray, and then input dot mouse. Oops. Input dot mouse position. Oh, something else I want to point out is at the very top of your code, I had turret rotate. I noticed this when I was looking at this today. Make sure that you correct this turret rotation position or turret rot position. We're going to be using that in a second. Okay, so we have a Raycast here that's storing the camera's ray that's being shot. So you can imagine this is an invisible red laser that's just kind of tracking our mouse everywhere. Okay, we're going to use this to actually rotate our turret. Okay, so let's continue on with our code. Okay, so we want to create another variable called hit dist and set that to 0. I'm going to use that to register the hit distance between when we click on our plane and the camera. It should be 0. It should always be right on the surface of the plane. All right, let's make an if statement to sort of calculate all of it. So I'm going to say if the player planes. Now this is a vector 3, so it can actually record rays. Raycast. Remember this guy. So this is a method. This is a pre-made method. And what we're going to pass to this is the actual hit and the out from coming out of the plane. So Raycast. And then we use the term out here. Hit. Okay, so what's happening here? So if our player plane registers some sort of raycast. So again, if we click on our plane, it's going to start registering. It's going to pass two variables, right? It's going to pass the actual raycast, which is this, and it's just going to send out a separate. We haven't done anything with this, but this is just the hit position anywhere on our plane. Okay, so if these are true, that we actually have a mouse moving around on our plane, we want to do something. And so what we want to do is store the position of where our actual ray is hitting the surface. Okay, so let's do that here. We do that using a vector 3. That's our data type. Ray hit point equals raycast. Oops. Raycast dot get point, and then we're just going to use hit distance for this. Alright, we need to create another variable, and this is going to store the rotation angle. So we do quaternion. If you're not familiar with quaternions, you should sort of look those up. I might create another tutorial later. Actually, I might make one before this one, so you guys can kind of play with quaternions so you can understand what they are. Really, just anytime you see quaternion, it has to do with rotating, like the halfway point between a rotation. So this is the data type, and we're just going to say target rotation equals quaternion dot look rotation the hit point, which is this, minus the current position. So we're looking at the halfway point between those. And the current position, as you already know, is calculated by transform dot position. Alright, I'm going to try to finish this up because we're reaching almost the 10-minute mark. Okay, so we need to further calculate part of the rotation. Hold on one second. No, that looks pretty good. Okay, so all we have to do at this point is turret dot rotation. We just have to actually use these values to actually make our turret rotate. It's turret dot transform dot rotation equals quaternion dot slurp. And I suggest, like, you highlight this, hit quaternion, hit the I think it's F6 for the help feature, or Control plus, and just look up what a slurp is. And again, I think I'm going to do a whole tutorial on just what quaternions are, because they could be kind of confusing. So our slurp's going to take 3 parameters that it's going to calculate the actual rotation. So let's break this up. And you can see where's the starting point of the rotation, and then where is it going, and then the third one is the actual value, the in-between value. So the actual starting point is wherever we're rotating from, And then the ending value is our actual target rotation, which is this guy right here. Zoom out a little bit. And then the third value is, like I said, how quickly it's going to rotate. So I'm just going to use time.delta time times rotation speed. Don't worry, I'm going to go all the way down on the code. I'm just looking for that turret rotation speed. Times. Alright, make sure that you have that semicolon at the end. And make sure that hit here is actually hit distance. So let's paste that in there. Alright, go ahead and pause this. Sometimes I'll do a screen grab. Alright, let me just double check this code myself. Okay, that looks pretty good. So let's jump back into Unity. I'm going to go ahead and press play. What you should have now is the turret following along the mouse position. Alright, let's look at it in multiple views so you can kind of see that. So here's this guy. And as I click, you can see it rotates. Our really crappy tank here. But, I mean, it works. Alright, we'll move on to the next video.